Welcome intellectuals to our today's wonderful tutorial. So in our today's lesson we are going to solve this interesting question which is coming from chemical kinetics. Okay, specifically on the rate holders, how we can determine the rate rule using the experimental data. Okay, so we have been given this question B3. This is just showing that this is a past paper question which is coming from 2024, which was on our section B, question 3. Okay, so the following rate data were obtained at 25 degrees Celsius for the indicated reaction. So this is the reaction 2A plus B is producing 4C. Okay, so what are we going to see here? We're going to say that this experiment has been given showing the three trials which were made for both reactant A and B, and the rate of formation of C were given to be this. Okay, so that means to say for every change for every concentration of A and B, this was formed. So the question is to find the order with respect to A and B. Okay, the order with respect to A and B. So the rate order, guys, just tells us how the rate of reaction depends on the change in concentration. Okay, on the rate in concentration, I talked about you guys that, for the example, the rate order for the zero order reaction is it. So the rate order, I used to tell you that the rate is in the form. Let's say, for example, I'll be using reactant K, the rate will be K, which is constant there, then concentration A. So if it is for the zero order, I used to put 0 here, and we used to remain with K because 0 to the power, any number raised to the power is just 1, so K. So this was showing that for a zero order reaction, the rate of reaction doesn't depend on any change in concentration, hence the change is all brought as a result of what? The reaction. So what we are going to do here, we are going to solve now this, we are going to answer this question step by step, because this question sometimes may be so confusing, but we are going to break it step by step. Okay, so for you who may have more questions, you can inbox me on this number. I'll talk more about why you should need to inbox me on this same number at the end of the lesson. So let's keep watching, guys. So don't forget also to share the lesson after you watch, so that others may benefit from this. Okay, so to determine the rate order with respect to A, I said that the rate order tells us how the reaction depends on a change in concentration. For example, in change in concentration of reactant A, it can be reactant B or any kind of reactant that has been given in the expression, or which are part of the reaction. So we want to understand the reaction, how the reaction responds when concentration changes. Hence, what is going to happen is that we are going to take two reactions. Okay, if we see, let's say for example, we can determine how someone, for example, changes his height as he is growing. Okay, as he is growing, for example, we are going to see the change in height when someone was 2 years and when someone was 3 years. Okay, we are going to determine the height. Okay, if the height is not going to change, if the age is not going to change, we are not going to consider that. Okay, the same way here, we are going to look about it. We are going to start looking at experiment 1 and experiment 2. What are we seeing in experiment 2? We are seeing that this is experiment 1, this is experiment 2. We are seeing that concentration for A was not changing. Okay, concentration for A was not changing. See, 0.1, 0.1. But concentration for B was changing. Okay, concentration for B was what? Was changing. Hence, we are going to use experiment 1 and experiment 2 to determine the rate order with respect to B, because it's only B, it's when the concentration of B which changed for these two experiments, but concentration A didn't change. From the definition, we want to see how the reaction depends with change in concentration, but we see that experiment A is not changing, hence we can't use experiment A, experiment 1 and 2 to find the rate order with respect to what, to A, because experiment A is not changing in these two in these two experiments. Hence, let's use this experiment 1 and 2 to determine the rate order with respect to B. So what we are going to do, we are going to do this. We are going to say rate 2 over rate 1. We can even say rate 1 over rate 2 is just one and the same. It's going to be equal to, okay, it's going to be equal to, because I started with the rate 2 over rate 1, that means even the concentration, I'm going to start with concentration 2 over concentration 1. Okay, we say, because we are looking for B, concentration 2 over concentration 1. All these are going to be raised to the power, okay, raised to the power x. Can use x, can use any letter. So what we are going to do next, guys, is just now to put, we know that our rate 2, our rate 2 is equal to, what is our rate 2, what is our rate 1, what is our concentration 1 for the reactant B, and what is our concentration B. Okay, so concentration 1 is 2.0 times 10 to the power negative 2, 2.0 times 10 to the power negative 4 there. Okay, then our concentration 2 is 8.0 times 10 to the power negative 4 there. So 8.0 times 10 to the power negative 4. Concentration 1 is 0.1, then concentration 2 for B is 0.2. So 0.1 and 0.2. So we just replacing the expression here. So I taught these guys on LS1, which I said expression of rate law expression. I taught all this, so it's just the matter of us to press this. So we say rate 2 is equal to 8.0 times 10 to the power negative 4 over 2.0 times 10 to the power negative 4, then is equal to, so what we do here, we are going to say, what do we have? Concentration B is what? Concentration B2 is 0.2. Okay, is 0.2, so we have 0.2, then over 0.1 concentration 1. All these are raised to the power x. So you can see that even without using a calculator, you can see that this and this can cancel. 2 into 8 we get 4, and here 0.1 into 0.2 we get 2, then to the power x. So simple mathematics here. We are doing logarithm and exponential functions, so we can't fail to say that this can also be written as 2 to the power 2, then 2 to the power x, so that this and this can cancel, and we equate the power x is equal to 2. So what you are going to say, we are going to write to say that you are going to say that the reaction is second order with respect to what, to B, because we are determining B. The reaction is is second order. Okay, or let me say I'm going to say simple English. I'm just going to say n is equal to b. I is equal to 2 with respect to b. Okay, n stands for the rate order. That's how you find this kind of an expression. So this, some of the students used to make a lot of mistakes on this. So just determine which one is changing, and you use the corresponding rate laws. So let's find the rate order with respect to A. Okay, so now when we look about experiment 2, okay, experiment 2 and experiment 3, what are we seeing? We are seeing now that B is not changing. It's 0.2 is 0.2, and so we are not going to consider it. We're going to consider experiment A, which is changing from 0.1 to 0.2, and this makes a lot of sense because we want to see the effects, or the how the effect of this change will affect the rate of reaction. So we are going to say, okay, let's skip this part. I'll use it for solving harder questions. So I'm going to say rate 3 over rate 2 is equal to, it is not a must that you should start with rate 3. The reason I'm using this, I'm trying to make sure that the greater number is on the numerator, so that I don't deal with too much of decimal numbers. Then you're going to say reactants 3 over concentration 2, all this raised to the power y. Can use any rate like I said. So rate 3 is no other than, okay, rate 3, so rate 3 is 1.6, rate 2 is 8.0, and the concentration are just one and the same. Okay, so rate 3 is 1.6, rate 3 is 1.6 times 10 to the power negative 3. Let me see, yes, times 10 to the power negative 3. Then rate 2 is still 8.0 times 10 to the power negative 4. Okay, so what we have, rate 3 is 0.2, for concentration 3 is 0.2 there, then concentration 1 is 0.1, all this are raised to the power y. Okay, so what we do next there, so when say 1.6 times 10 to the power negative 3, then what do we have here? We are going to have 4. This is giving us 3. Okay, this is giving me 2, not a 3. Then here we have 2 to the power y. Okay, so you can even see that since here is same as 2 to the power 1, so we can just cancel this, we equate the powers. So that means the rate order is 1 with respect to reactant A. That's how simple you answer question 1. So the other question that they can ask in other questions, they can ask you to find the overall order. So the overall rate order is going to be found now by, so we write it as the overall is going to be equal to the N for A, or the reactant that you have, plus the rate order in B. So we're going to have first is 1 and B was 2, so the rate order is third order with respect to what? to all the two reactants. This is when you are asked, otherwise this question wasn't asked, so just ignore it. But in case you are asked, that's how you go about it. Okay, so now the next question is to write the rate law expression. Okay, I said the rate law expression. I don't have very few space here. The rate law expression is in the form let is equal to K. Now because we have reactant A, we are going to say A, and reactant B. Now going to add, this is going to be what we did we how we have Y for A and X for. So just replace the value which we found. So with A we had 1, with B we had 2. But you know that this can also be written as, because A to the power 1 is just A, so just write A, then B to the power 2. Okay. What is the next thing that I've been asked? We've been asked to find the rate constant. Okay, to find the rate constant. So rate constant has got 4 marks, but it is very simple, but it becomes difficult just for the issue of finding the units. Okay, but I gave a very simple formula on how you can find the units, so it's not a big deal. So how do we find the rate constant? So we go here. You see this same expression. We are just going to make, this was the rate law, that is, I'm sure it's question B. I don't know if it's question B. So what you're going to do, you just make A the subject of the formula. So that means we're going to divide by A, then B to the power 2 everywhere. A, then B to the power 2, so that this may cancel. Okay, so this is now going to be, I don't have enough space as you can see. Okay, so we're going to say the rate constant K is going to be equal to, so what you see, you are going to take any, because the formula becomes to be this, A, B to the power 2 over, on top we have rates, so the formula is this, so on top we have rates, then A, then B. Okay, so how can we find the rate constant now? We are going to take any experiment. So as for me, I'll take experiment 1. I'll take experiment 1. So the concentration for A is 0.1 and the concentration for B is also 0.1. So that is what I'm going to take. So you are going to do, so I'm going to do this. So we are going to say the value of K. Let me write it here. There's a space here. The for experiment 1, the rate is 2.0 times 10 to the power 4. 2.0 times 10 to the power negative 4. And concentration A, I said, is 0.1 in experiment 1. Even in experiment 2 is also 0.1. Now squared. So the rate constant, once you add this on your calculator, are going to get the rate constant, which is going to be equal to 0.02. 0.2. Okay, so now reading this answer like this, it can make you lose marks. Hence you're going to find the units for rate constant. So the rate constant, the units, I give you a simple formula to say that it is m1 minus n, then per time. What I mean is that this n is the overall. Okay, what is the overall do we have? The overall order is 3, so we are going to say m1 minus, here we are going to put 3, then t to the power negative 1 there. So 1 minus 3 just m minus 2, then t to the power of 1. This t is just showing the units of time. So in this case, the units of time that were used were, let me show you here. The units were, as you can see, we have minutes here. Okay, we have minutes. So that means to say it is per minute. If you had second, you would have said it is per second. So we're going to have m to the power negative 2, then per minute. These are the units. These are the units. So sometimes this question can be a question on its own. Find the units of the rate constant. Okay, so know how to find using this simple formula. Okay, m1 minus n, then t to the power negative 1. Okay, which can be in seconds, minutes, hours, whatever, but they usually the range may be just in minutes and seconds. That's all. So the next thing here is to find the initial rate of the reaction when this concentration and this concentration are given. How can we find the initial rate? Okay, so from the rate holder that we've already found, okay, we have the rate holder already. The rate is K, A, and B. So just failing to answer one question correct can cost you all the marks of the question, because as you can see, if you made a mistake here, that means here you are going to write the wrong rate law expression, the rate constant will be wrong, and this is going to be wrong, and you can't find the correct integrated rate law. Okay, so it is going to be very difficult, so pay total attention whenever you are dealing with this. Okay, so what you are going to do is say rate, the initial rate is going to be equal to K, we found that is 0.2, and A is 0.4 there, and B is 0.3 now squared. So what is going to be our initial rate? Our initial rate will be no other than so it's going to be 7.2, say 7.2 times 10 to the power negative 3. Okay, the units for rate is molar per minute. You can even know that you have already given that, it's molar per minute. That's how you find the rate. So now let's sketch the graph for the integrated electrode with respect to the reaction order of reactant B. Okay, so reactant B, the rate order is 2. Okay, so now how can we find the integrated electrode? The integrated electrode for the second order. Okay, I taught on of this, so I'm going to show you here. For a second order, the integrated electrode is given by, so it's given by 1. So since we are using reactant B, we are going to say 1 over, this is not new for you guys already studying the already we did this, is equal to KT. It is the one which has a positive rate constant plus 1 over B initial. What did I tell you guys? I told you that in this case our slope, so mention this because we are asked to sketch, not to actually plot, so it's just a sketch, a simple sketch. So a slope is K, this K is a slope. Okay, then the graph, the same way we have that equation, which is, let me write that equation. I used to make you guys understand. So mx plus c. So you can see that a graph is always between what? The graph is always between the y-axis and the x value. So the x value is see, as you can see, the y value is this one. So the graph should be x versus y. So the graph is going to be the graph is going to be a graph of 1 over b versus time. Okay, that is the slot, that is the graph. Then the intercept, here you mentioned the intercept is going to be equal to 1 over b initial. So this information, you just say that since this is the y-axis, this is the x-axis. So in the x-axis, what are we going to have? We're going to have time in minutes. Okay, then what are we going to have here? It is a 1 over the concentration over the reactant there. This is actually in molar. Concentration is in molar. So it's just the matter of you doing a sketch. The graph of this is always a straight line from here, so it will move like this. That's how the graph is going to move. You can even label it as the graph of 1 over b is equal to k plus 1 over b initial. So all the videos which I explained this for the second order, for the first order, even I explained on how you can find the half-life, even solved a lot of questions. We have those videos that are recorded. So this is how you answer this kind of a question, guys, and gain all these marks. You know, this question had about say 20 marks, and you can't miss all these 20 marks in an exam just for this simple question. And the question on this always come in an exam. So just follow all the steps that I was giving you guys and enjoy the free marks that you are going to see. So guys, don't forget to register for our tuitions. Okay, let's help you guys to finish semester 2 very simple, in a simpler way. So just inbox me on this number. Registration is just going at 70 kwacha per course. Okay, just 70 kwacha per course. We offer tuitions in both biology, in fact in all NS courses, biology, physics, chemistry, and mathematics. So register with us. You can inbox me on this number. Okay, let's not just see the issue of 7th quarter cost you a lot of marks. You even know that people, they tell that chemistry, semester 2 years chemistry is difficult in terms of some concepts. Of course, these are simpler concepts, but you're going to get into the most complicated chemistry. So just register so that we help you guys. So don't forget to share the video. Thank you for watching. See you in the next lesson.